While there are an array of different utopian and dystopian visions for how the future could unfold, it is likely that the future shaped by information technology will be a mix of various good and bad outcomes. This means acknowledging not only utopian dreams, such as pervasive automation or universal connectivity, but also the dystopian risks, such as privacy invasion or inequality. As technology evolves, societal and ecological impacts become more complex and unpredictable. Human creativity, ingenuity, and the tendency to desire more convenience are powerful forces in this process. Consider the development of smart cities, which integrate technology into everyday life to improve urban living. These cities use sensors and data analytics to manage resources efficiently, providing examples of both potential benefits and drawbacks. On one hand, they reduce energy use and optimize traffic flow, promising better quality of life in urban spaces. On the other hand, they can lead to surveillance concerns, data privacy challenges, and exacerbate existing inequalities by prioritizing areas already well off. This intersection of technology and reality touches on fundamental themes in sustainability, environmental stewardship, and digital ethics. Resource use becomes a central concern as smart technologies demand energy and materials. Ensuring equal access without deepening societal divides remains a challenge, and the push for innovation competes with the necessity to protect ecosystems and biodiversity. The technological landscape itself embodies these mixed outcomes as innovations simultaneously solve and create problems across interconnected systems. Renewable energy technologies demonstrate this complexity. Solar and wind power reduce carbon emissions and air pollution while creating new material, demands for rare earth minerals, and challenges for grid management. These technologies have become dramatically more affordable and efficient, enabling rapid deployment that many thought impossible a decade ago. Yet their manufacturing and eventual disposal create environmental impacts that, while less severe than fossil fuels, still require careful management. Smart grid technologies that optimize these renewable resources improve system efficiency, but raise concerns about cybersecurity vulnerabilities and centralized control of essential infrastructure. Digital platforms similarly reflect this mixed reality, creating unprecedented connectivity while introducing new forms of alienation and manipulation. Collaboration tools enable distributed teams to work together across continents, reducing commuting emissions and opening economic opportunities previously constrained by geography. These same platforms collect vast amounts of behavioral data that companies use to shape user behavior in ways that promote engagement over well-being. Open source movements counterbalance these tendencies by creating technologies governed by communities rather than corporations, demonstrating alternative development models that prioritize transparency and collective benefit. The resulting technological ecosystem defies simple characterization as either liberating or oppressive. It is both simultaneously, with outcomes shaped as much by governance structures, cultural values, and economic incentives as by the technical capabilities themselves.